I'm Dr Carl Larsen. I'm a senior lecturer in biological sciences at Liverpool Hope University. I'm an evolutionary ecologist, so I look at how an animal's ecology and behaviour shapes its morphology. I look at those morphological features in an evolutionary context, so I look at whether genetically similar animals have got similar morphologies. What's more interesting is when they've got quite different morphologies and when genetically unrelated animals have got very similar morphologies, and I try to see whether there's something in the behaviour that causes that change in morphology. The common feature I'm looking at today is bristles, and bristles in birds. There are about 10,000 bird species on the planet, and so far we've found that about 500 different species have got facial bristles, and that in about 70 different families, so it's really widespread. They're most similar superficially to bristles in mammals or whiskers in mammals, and it makes sense for mammals to have whiskers because they use them for sensing the environment, and because the majority of mammals are nocturnal, that makes a lot of sense. So just think about your pet cat going hunting at night, sleeping all day, or your hamster on its wheel running around keeping you awake all night, chewing the bars. Mammals are nocturnal. Birds, on the other hand, 97% of them are diurnal, so it's really unusual to find whiskers or bristles. So the group we're looking at are a group of nocturnal birds called the caprimulgiforms, and one of our theories is that those group of birds use bristles to sense their environment, rather like mammalian vibraceae or mammalian whiskers. So we're calling that the feeling theory. So they can feel the environment, they can feel the babies if they're trying to feed them, they can feel for food, sense things. Another theory is that nightjars and similar night birds use bristles for mechanical protection. So if they're foraging in the dark, flying amongst vegetation, feeding on beetles and flies, the whiskers will protect their eyes from vegetation poking them in the eye or the legs of grasshoppers and stuff sticking in their eyes. The final theory we're considering today is one related to whiskers or bristles and nightjars as an aid to foraging, really, to increase the gape of the mouth to bounce prey. So if a nightjar's flying in the dark and it doesn't quite line up with the prey, it can adjust itself last minute and use the whiskers to bounce the prey into its mouth. So we're calling that one the feeding theory. In order to test theories about the function of bristles in nightjars, we first had to describe them, and we spent quite a few weeks in museum collections at the Natural History Museum Tring in Hertfordshire and at the World Museum in Liverpool, and we summarised the range of bristles in the following illustrations. In order to test theories about the distribution and morphology of bristles and nightjars, we had to cast them into a phylogenetic tree, which essentially shows the genetic relatedness of the different nightjar species. And if we just focus on the coloured boxes in the top left of the graphic, they relate to how complex the habitats are. So they go from very open habitats to grassland, to rainforest and enclosed habitats. And if we just start with the kind of older species like the oilbird, the potters and the frogmouths, they're all deep forest species. They tend to be very bristly. As we move out of those habitats, birds move into semi-open habitats with the eared nightjars, and bristles become vestigial, so they're no longer functional. Then when we move back into more dense habitats, Gactornis develops these very long down curved rictal bristles that are probably for mechanoreception. Bird species then move into more open habitats, and the New World nightjars, they tend to forage on the edge of forest in semi-open habitat and require bristles for mechanical protection and possibly to bounce prey into the mouth, so as a feeding aid. Then we have species such as Nyctiphranus, which nest in rainforests, and the bristles are very similar to Gactornis, so they're a rainforest species. They forage by flycatching from a perch. So bristles are probably for mechanoreception. New World species such as the nighthawks, they forage in daylight, often and very high above the ground. They don't come into contact with any vegetation, so they've completely lost their bristles and no longer require them for mechanical protection or for mechanoreception. And then we end up with the Old World nightjars, the European nightjars, the African nightjars that forage very similarly to the New World species on the edge of the forests in semi-open habitat, where bristles are required for mechanical protection and possibly for feeding. So in conclusion, we think that in species that forage in dense forests, bristles are used for mechanoreception, so to sense the environment in terms of touch. In species that forage in semi-open habitats, bristles are for mechanical protection and possibly to aid in prey capture. Finally, in species that forage in open habitats, bristles have become vestigial. We're doing further work on this now, so if bristles are used for mechanoreception, i.e. touch, we're doing some histological work now. We're expecting to find lots of nerve fibres at the base of these bristles, and that'll help us conclude that they are for mechanoreception. If bristles are used for mechanical protection, that we're expected to find fewer nerve fibres because they're just there as like a crash helmet. So that's what we're currently looking at. A nightjar miles courtesy of my son Elijah.